F3, our third problem, mass on table with pulley. We did one like this earlier without friction. A little pulley there. And we're going to be pulling the mass here, say, a fixed table. Call that mass 2. Call this one here mass 1. We'll pick positive direction to be like this. So this is the sketch. And now we want the force diagram. We have 2 masses, so we're going to have 2 diagrams. Mass 1, mass 2. Now for mass 1 here, we're going to have a normal force. We're going to have here a weight, M1G. We're going to have the tension in the rope pulling to the right, and we're going to have friction. For mass 2, now here positive is to the right and then positive is down, so M2G, this is positive direction just to be consistent, and this is T going up. So now we're ready to write the equations down. So Newton's second law. Newton's second law. So here we would have T to the right minus F to the left is M1A. Go ahead and do this one. M2G pulling down minus T is M2A. And then there's an extra equation here that N going up minus mg and 1g going down is going to be balanced. You know, it's going to get you 0 here. Okay, now you have the auxiliary equation, the friction equation here. This is going to be mu s n. And now we're ready to do the solution. Step 4 is to solve. I like to start here last and work with these 2 equations to get F is M. Oh, this is, by the way, a kinetic case because this is moving. Now, if it weren't moving, this would be correct the way I have it here, and acceleration would be 0. But since we are looking at a case where there is motion, we're going to make that a kinetic. That's going to have to be a kinetic coefficient of friction. All right. In fact, it might be good to just put that in the diagram up here that there's a mu k floating around. Okay, so that gets us mu k times m1g, and then going to the first equation, I would have t minus, put this in for the f, mu k m1g is m1a, and now I go to the second equation, and I'm going to add, which is using Newton's law of action and reaction, since the tension has opposite signs, see, when you look at the 2 equations. So if we do this, we'll have m2g minus t plus t, that cancels, and then minus mu k and 1g, and then the masses add up. There's like 2 masses. So I'm just going to put here m1 plus m2 times a. and we want to find the acceleration. That's the standard thing. In a problem like this, standard is to find the acceleration and to find the tension in the cord or the rope or the cable. All right, so here we're going to factor out G. We're going to factor out G here. So this will be M2 minus mu K M1. So the G comes out, and that's going to be equal to this. So I divide by the sum of the masses unfinished. So let's do that. A is M2 minus mu K M1 over M1 plus M2, and that's going to be times G. So that's the answer for the acceleration. Go ahead and box that off. Now, a quick check on this. If we let the friction go away to check what happens, because we have an answer from the previous chapter, if we do this, then the acceleration is going to become M2 over M1 plus M2 times G. And if you look back in chapter E, section 2, that's what you're going to find. So now we want to go with the tension, and here the T, I think here you could use either equation. I think my preference would be to use this one here. So that would mean I would have M1A. You could use the one with this with 2, the M2, but I'm going to use this one. I get then M1A plus mu K M1G. And then we have to put in for the acceleration this term and then do the algebra. So if we do that, we get M1 M2 minus mu K M1 squared, and that's all over the sum, and that's going to be times G, and then I have plus mu K M1G. Now if I want to add these together, what I'm going to do is multiply the top and bottom of this one by the sum of the masses. All right, so if I do that, then I'm going to have in the denominator M1 plus M2. And it looks like G can be pulled out. So here the first one is going to be M1, M2. Then it's going to be minus mu K M1 squared. Then here I'm going to have a plus mu K M1 times M1 is going to be M1 squared. And then I'm going to have a plus mu K M1 times M2. Okay, now you can see that this one and this one cancels. They go away. And we're going to have our answer here. We're going to have, for the tension, looks like we're going to have the product of the masses, M1 times M2, and we're going to have 1 plus mu K. I'm going to factor that out. That's going to be over the sum, and that's going to be times G. So now, if mu K slides to 0, the tension becomes M1, M2 over M1 plus M2 times G. And if you look back in the chapter E, section 2, where we did this problem, you'll find that that checks out. That's good. So we have done it.